All right, welcome everybody to another episode of Labs Talk. Today we have two guests, Adelya and Lukasz. Thanks for joining us. How are you?
Good. Thanks for having us, actually.
Perfect.
Yeah.
So we're going to talk about robots once more, actually. Right?
Yes, indeed. First of all, welcome, Adelia and Lukasz. Thank you for being here. You came here to talk about embodied AI, and when we planned for this episode, we figured out we have been talking about embodied AI pretty much a year ago already. We did a series on AI in 2024, and it turned out all of this went under the big headline of robotics, and it was more like AI and robotics. Now it's the other way around. But we did have guests last year. A couple of pretty.
And I remember we talked to Renee from Reply, right?
Yeah,
But we also did actually health and robotics. I remember we actually did that last year too.
With Devantro,
exactly.
This Munich, I think Devantro was the first in the series where we talked about robots in healthcare or in elderly care. That was the use case they had. And we spoke to Renee from an SAP partner. Actually, they did a couple of all different kind of use cases. We looked at pictures and videos from those four-legged robots, but also this Ameka, I think, was the name where the purpose of the robot was to give facial expressions. And we spoke to a PhD student in Technical University, Oliver, who did coordinate swarms of drones. That was
to skill up. We also tried to create some drones and stuff like that, right? Privately, I believe so.
Yeah, but that's another life already.
But then you guys are already experts on this topic. You should be the ones to
let's stop the episode, okay?
I mean, no surprise. Robots is not a new topic necessarily. It's around for decades. Just that there's a lot of very cool stuff that happened in the past year about it.
Totally.
I think we just talked a bit about it actually before the recording, right? So the special new thing here is that now we have AI and we have agents, plus we have robots, right? And that's, I think, what we'll discuss a lot in this episode. But before, should we maybe...
Let's start differently. We talked about Labs Talk and what we did so far. Adelia and Lukasz, maybe let's start with a quick introduction. Let's really introduce yourself. Tell us what you're doing and why we invited you to this episode.
Well, it is a show about robots, so clearly I'm doing something with robots, but my background has actually nothing to do with hardware. Rather, I started in bioinformatics, so I'm also a big fan of the digital health topics and everything like this. I started at SAP 10 years ago in the health team, which is actually how I met Lukasz. And now, for a few years, we worked together in what was Innovation Center Network, and now it's Research and Innovation. And obviously, robotics, embodied AI is a cool topic, innovation topic, Cool. And for that, I'm the global architecture lead for SAP. So
awesome.
Yeah.
Perfect.
Okay, so I'm Lukasz. I'm driving the innovation out of Potsdam. And for the last 5 years, we try to come up with different topics and identify which technology fits for SAP, how we should position it, where it makes sense for us to explore. And we pick up robotics in early April. And that all led us here to that I wanted to explore how it makes sense for industry, because human healthcare, human care, this is important. We see lots of work there. And we say. And then in our try, what it makes for industry? Can we apply it to industry? What it makes for our customers, SAP, robotics, and what our role plays in there? And that's what we try to do. And I think that's how you.
So in industry, as in like supply chain, for example, right? What do robots do in warehouses?
What do they do?
Okay. Well, let's see a robot in a warehouse, maybe. Okay. So we all know what we're talking about. Let me just switch over here, basically, and then play back the video here.
We really work closely with customers to make it a reality. And now I'd like to show it to you in action if I would see my demo coming up here. So here I'm now a warehouse manager, and you know the usual drill, right? You see all your warehouse tasks, and I do it usually in a very manual fashion. But now I want to do this in a very unusual way. So of course I go ahead here in warehouse management, right? You see all these various tasks. I open Joule.
So it's like the place where warehouse managers would normally.
And when I open Joule, of course, hey, take care of this urgent customer delivery that I have here and do the respective picking. Now, Joule thinks, of course, through the usual workflow, and it decides to actually delegate this task to a humanoid robot here in the Experience Center at TechEd. Now, Joule determines it was a picking action, and before it delegates it to a robot, collects a bunch of actions from EWM, and now sends this over to the robot, which we should now see here, And now it, of course, goes ahead and it notices the robot is a missing branding label on the box. Joule helps the robot to resolve that according to the process. And Anura, for anyone, actually inspected it in real time. And based on an ad hoc task from Joule, puts the defective item into a quality bin.
system.
And as a next step, actually, it's now fully done. So Tex also picked up a good item, actually, now. And the process can be essentially completed and continues the task, picking the high-quality item. And then we actually see here in warehouse management that the task is completed and the order is now in progress. And of course,
picking, there was a defective label. And like normally this process takes time, right? Because like you have a worker who has to really respond to that, put that in a quality bin, and then restart the task. Here, because this robot's connected to SAP, we actually just directly create an EWM task in order to handle the ad hoc quality bin, placement action, right? And then that's actually the cool thing. I think we'd see it so fast here that it doesn't really come across so much, but it's really like a big manual step that we are now skipping from this. So
you basically took away my question. Like we have this picking machine downstairs here in this building, which is very like it's a huge robot after all, but it's not very intelligent. It has like two axes and it picks from a very symmetric.
Well, I'm glad you asked that, although you didn't actually say your question in the end. But if it's like a super well-defined known process the same every time, right? You don't necessarily need AI agent-powered robots. However, what if something unexpected happens?
Yeah, exactly. I just wanted to talk about flexibility, right? So when would I use such a flexible robot versus, of course, if the task is changing, right? So
exactly, when you have a task that require changing demand, the changing circumstances, or environment is changing, then you want to have more and more understanding of what's going on. And that's a little bit our approach is, because now you see all the robots being trained with like a general purpose robots and general purpose models, so they can pick up a box. That's great. I mean, technically, physically, you can pick up the box. But why I'm picking the box? Where does it go? What happened when something circumstances change? Like all of this is business context, which robots don't have, and you can't really train them without being in the business context. And all the companies are training robots right now. They have no access to this business context. So customers will not let you train the robots on the business data or business process because that's the business, the IP, and they want to protect it. So we try to find the balance where we can enable certain business knowledge to the robot so they can be out of the box working in the business.
So only to pick up a few words here and to rephrase what I understand in a nutshell, what you're trying to do is you're trying to do research and to give Joule, our AI product, arms and legs to execute.
And eyes, yes, exactly.
And eyes, if you want to, and so that
and the loudspeaker
AI.
Why not? Right? Everything comes.
It actually becomes the interface of SAP. Like you want to interact with the robot, to interact with SAP, and that's also the new experience that you're gonna have.
But I think that's also what we discussed in the pre-chat. So we're not trying to build these robots, right? But we're just trying to interface with them, right? So because there are many robot companies out there, robotic companies, and they do a great job, right? So we're trying to be like the next level of connecting to these robots from an enterprise system.
Exactly. Yeah? We want to be the end user for what they can achieve, and there are so many different robots. So they have different capabilities, different skills, different size. They all fit differently to our customers' purposes, and that's why we try to be agnostic to. This is you know your process. Now you have to find the right robot for your tasks, and increase your throughput or increase your quality of the activity.
And that basically means when you give a task to the robots, let's say a task comes from, so Joule is this agentic system, right? And it thinks up a task where a robot could play a role, for example. Then is it a high-level task like go pick this product? Or is it something like forward 5 meters?
No, I can answer this. So we as SAP have no idea how to operate stuff in the real world, like coordinate 30 motors to perform this like arm action, right?
Yeah.
That's not our expertise. That's what the partners are for. That's why it's very much about like the ecosystem and working with different robot vendors. Now, what do we do as SAP is we give those robots a purpose to exist. No one creates the super expensive robot and puts it in a warehouse for it to do nothing. And SAP has the tasks. I mean, we have the context. We know the items to be picked up and when. We know the special process to handle the items. We actually also know how to handle exceptions and defects. And this is where it's like something I think actually quite special because the real world isn't perfect. It's also, by the way, a great use case for agents. Right? I would say, I think I said in my intro, I'm coming from development background. Most cases where you're trying to use AI and agents might not be the best choice. But here in the real world, it's complex enough that you actually do need agentic AI. And then from SAP's side, we have all of the situation handling stuff defined already, right? So we're not coordinating motors, we're communicating this higher level business.
So and our like a ideal direction is we want to give the intent what to do, like execute this order. And that's what the user should give. And then all the information will pull from the right systems, put in the right context to give robot actions. Even further, we try to do is even the actions perform. And we talk about not just one action, but the multiple robots you work in this in your landscape. They all perform tasks that eventually impact your business outcomes. They eventually impact your business financially or make some changes. And even that changes, then we can take it, analyze it, and then go back to the robots. Hey, we saw how you operated. Now let's modify a little bit how you work. Maybe pay attention to this variable, maybe pay attention to this site because there will be some errors there. And that improves your final business outcome. So really it's combining the digital business knowledge with the physical executions that we try to bring the value.
Maybe to mention, it's not impossible today. There's many like one-off pilots of this type of thing. I think the question is, can you do it at scale? And that's where we have some advantages.
And I think there's a lot to unpack there. I was trying to connect that back to the previous conversations we had. Like we were talking about Devantro in chat before, and they resorted to telepresence because exactly that reason. That's just one of the things that I listened to, and they didn't focus on motors and everything, but the care. Not a related use case, obviously, but the same situation. They had to navigate around real world situations, and they resorted to telepresence. And now you're saying you're putting that layer on top and put an agent there, and basically you're making the robot just take an order, like go into the real world, go figure out how to get some water from a
deal with it, like
deal with it, figure it out. And when we spoke to René, he was talking about the hardware platforms, the four-legged dogs, the humanoid robots and everything. And that's nothing you care about either, because again, you just put the idea.
We need the things to work.
Obviously,
right?
And we care the end-to-end scenario because for our customers, we want to make sure it's going to work end-to-end. So the robot dogs, they must perform and must be compliant, must work and must be safe. So to all of this, we also care about it. But just we give it to partner to demonstrate the capabilities that we're going to apply to our scenarios.
So there's a lot of different robotics systems, platforms out there, right? And I guess you must be interested in having a good standardized interface. Is this something you're investing in or working on basically, or are you basically picking one best vendor of robots and go
maybe
for that?
I start and then give Adelya for the all technical greedy details. I think our approach is also based on the tech agent to agent. And when we talk to our other robotic vendors, they also want to have their own interface as an agent, so that we communicate our intent, what we want to do, to understand the intent, and then execute through all APIs, internal processes. So that makes this communication much easier. And because they're also realizing this is the future, they're working on this, and we're working out together to figure out maybe even the best standard how the agent should communicate at this robotic software layer.
But then just quickly, so agent to agent, right? That's something like MCP, Model Context Protocol, is like, but on an agent level, it's a protocol I think invented by Google, and most people or many people will know it from a software context, I guess, right? Agents like Google agent talking to a Microsoft agent, talking to an SAP agent or something like that. And now we have agents in the real world, basically, right?
Wait a second, like just to bring in that thought that I have now. What this is going to is not a binary protocol. So are we going to see robots hugging each other and shaking hands? That's like a sort of protocol in the real world.
I mean, maybe let's talk about why LLMs seem to be so powerful, but on the other hand can be a little bit disappointing. It's because as humans, a lot of our intent and meaning is really just in language and in words, right? And A to A, I think sometimes can sound like a bit silly, but it's true that these robot vendors are really looking into creating a higher level abstraction for how to coordinate the robots. And that's not about the joints, right? All of that stuff is still done with existing standards like ROS. It's rather about more the task delegation. So like from that perspective, you can look at robots as tools for agents, where MCP comes into play. And if they have...
my apologies to have to interrupt for that, because in another episode we had before, Oliver from the Technical University, he was talking to us how they train robots to touch and pick up things from a different thing. And they basically pipe that physical data, that real world data into more or less an LLM, a neural network to do the very same thing, not on words, but on physical coordinates and movements. And they train that. And that's what you're saying. That's, again, that layer beyond that robot vendors
but
do.
you also have to think of what SAP's part is in this. Like, we cannot tell you how tightly to grip an item, but we can tell you the attributes maybe of that item. So like the weight, the texture, the dimensions, this kind of thing. So like from that perspective, I think a lot of people look at A2A as like a magic bullet, that, you know, everything's natural language. So now you're going to magically understand what I want you to do. But I still, if I want you to go pick up an item, I still have to tell you where it is, what is it, how to pick it up. So there's certain data points that you still have to like actually communicate because that's what the task is. And from that perspective, just because you communicate this now in natural language instead of sending a JSON doesn't necessarily mean we've solved the problem.
That's true.
Exactly. And I think what's coming is new because now the robot performs the task in real world. We have lots of new data. We have the task data, which is how they perform the task, all of these parameters that we can consume. Information that just surrounding information, ambient data, observation data that I can also consume. And if you know all this information that today don't really exist in industry from the execution level, we can now combine, analyze, and have extra digital points for optimization. So that's also some extra points, not for the robot execution, but for us, for the business side, hey, what we can do, what we just learned.
Yeah, but you asked about standardization. I'd just like to add another point there. I think for us, I mean, I mentioned robotics is quite an old topic, but you see a lot of advancement happening very quickly. And like part of that is, of course, because of the huge investment happening in this topic, right, from many big tech players. Part of this is actually also because of more like standardization. So like, for example, to create ChatGPT, you had the internet as a data set, which was huge. But when it comes to, say, like robotics, there are companies that want to do physical AI foundation models, but they need to create the data sets. You can do that by open sourcing your data sets. You can do that with teleoperation, as you mentioned, right? Which is pretty cool. No, you can have people do the task, and as they do the
record
task,
it as training.
I didn't think about that, but with that, I could imagine like the humanoid robot has a benefit because there is so much more data to
That's
train
exactly
on,
the
right?
case. So even though robot dogs, you see them already out there in the world, drones, right? Tons of drones. The big hope for general purpose humanoids is because the volume of human training data is kind of infinite. You can imagine a future job is you can be a human at a robot training center and you wear some sensors and you just, I don't know, do some stuff, right? And that's now a career. Could be a very funny one.
I want to be ninja warrior then.
A robot trainer.
Robot trainer. But I mean, for
but I think that's not
telepresence.
necessarily. I mean, teleoperation, that's what we see is also very interesting in the early stages. We have some projects where we have customers using employers working from home, operating the robots in the warehouse on the logistics center, and that's obviously because it was like remote. They're living far away from the place, so they have to commute. They can work from home, and that collects the data for training on our purpose, and also that they're contributing already to the business. So we have some projects like this, and obviously moving forward, we have the situation where we can fully train all the robots to be 100% out of the box plug in industry, because as I said, every process is different, slightly different warehouse, different way how we operate, interact with each other, different culture in the organizations. That all of us is this fine tuning that may come later. But also we come with SAP and we can support that the final last mile of training, we can say.
Cool. So we covered A2A, and I think in our pre-chat we also talked about what you're essentially trying to do is like you're trying to enable all the SAP LOBs to more or less execute on physical tasks, right?
Yeah, and every time we have a task to perform in physical world, we are the team to make it happen. Yeah. And we try to communicate exactly. We can able to source all the tasks that we needed, and then we communicate back to the robots, and we pick the right robots for you, pick up the right capabilities, work with the right vendor, so that can be possible.
And I think right now the focus is on SCM, right? So supply chain management. So that's all the warehousing, for example.
Manufacturing.
Is there another area that you're also looking into that might be interesting for?
I think the one we also found out of this was the health and safety. That's interesting because it works with the visual inspection models and like dog robots walk around, make sure you're compliant, to make sure everything is set up, your fire extinguishers in that place. Obviously, the pieces that comes handy on top.
But then you have so like warehousing logistics, right? Then you have like this whole like asset maintenance, inspection, health and safety. Maybe shout out to Digital Product School, because we actually work with a team of students from there that's going to present later today. Health and safety based project, right? They're also very interested in robots for safety inspection. So yeah.
Yeah, very nice, very nice.
Yeah. Maybe you think in the future managing your robot workforce via field glass or something. So who knows?
Super
We've
exciting.
seen those headlines before.
You've seen it with AI agents.
Yeah,
AI agents
it
in the work
happened.
chart.
There are startups that advertise like that.
I know, seriously.
Yeah. Coming back to all of that goals that you're pursuing, and you're creating this abstraction layer. With that, there must be some sort of general approach that you have, and you probably won't go for a specific hardware platform. You were talking about abstraction. How do you avoid this vendor lock-in or being too specific? Is that something that vendors already provide today? And is the standardization in that field that far advanced already, so you don't have to specialize?
Yeah, it's kind of tricky because every vendor slightly have their own approach. And we have some vendors that they want to make sure that they have just one entry to their robot, and then we try to consume that. Others will offer us through fleet management. Others will go as a set of different robots together because they have different their own platform we have to connect to. And I think we're still figuring out what's the right level of engagements. But if that's what they're offering, we just adjust. And that's on our end. We try to make sure what our enders is very agnostic, but that's Adelia's core challenge.
Yeah, this is my challenge, right? How do you make something that can be generalizable? Answer is just try to get more evidence. So the more robot vendors you work with, the more exposure you have to this ecosystem. We also have the advantage that on the robotics hardware side, they are standardizing a lot too. So they're also moving towards like a common set of like principles. But I think at the end of the day, if you think about it like this, if you want to tell another person to do something, there's like some basic attributes that you have to share. So like there's a set of data points that's kind of like given that we have to provide for different robot types. But then the question is like, do some of them need more detailed instructions? And can we as a SAP provide that, right? So like if it's like say item position, weight, color, okay, maybe. What if it's like something totally different, right? Maybe we don't have that information.
I mean, we also got lucky with the timing. Because whenever we approached the robotic vendors, we were on the first to even propose industry-specific context, and they were like very open to, let's try it out and see how this operates. And even someone were asking us, because of our Joule and our agents strategy, they also, hey, you're doing agents. Tell us how you do agents. Like guide us a little bit how your best practices. So we also influence them how they're gonna build the agent on their end. That we stick. So we got lucky with the timing, I think.
Yeah, that's true. I've actually found so we have the SAP Architecture Center. I found that the pages on building agents have been super useful when also talking with robot vendors. Because they seriously actually want to build agents to expose their robots. Because I said it earlier, like why do you build this expensive robot if no one's going to use it, right? And like I think that's actually a really good example, because like agents aren't something that's like only SAP, but like we're having this ecosystem where, you know, Microsoft agents, everyone's agents, right? That kind of thing. And I think, I mean, again, it's not a magic bullet, but it actually does help a lot. So
I just had this imagination actually of a robot in my home actually. So I mean, the smart home becomes really smart, right? Once you have a robot walking around doing the dishes and stuff like that. And we had examples of that actually in media, I believe. So
there's so many examples of that.
You're focusing, of course, on the industry, and that's probably a good focus, right? Because this is where initially, I guess, a lot can be moved in a relatively controlled environment, right? If you enter the homes, it's probably a different complexity.
There's lots of safety for like interacting with people. And then I think in the factories, and you can still have some space that you can dedicate the space when you can see what's operating.
Or like, you know, robot dog, lone wolf, like inspecting some electrical station, right?
Or looking at night also.
There must be lots of individual, say, reuse type of services that you can use in different places, like walk to that place you can use in an industry setting or at home. And that all of that, I can imagine, can be broken down into reusable services.
Sure. I mean, if general purpose humanoid robotics comes true, those robots can do anything in the home or at work. But I think really in the workplace, it's about the scope. We actually have a bit of an advantage because sure, unpredictable environment, but it's within a certain scope. And like we also have a lot of those things very clearly documented. So like in the home, I don't know what happens if I don't know what can happen in the home. Your fridge explodes. Well, maybe that example, but I'm just saying that like in the workplace, we actually have manuals for those things. They say what people should do. That's something you don't necessarily have in the home. No one's written a guide of how to respond to the
I can share stories about that exploding fridge.
Exploding fridges.
I hope not, right?
So
my point is in the workplace, you have
Vacuum.
a lot of those kind of guidelines and governance that are an advantage.
Which also in SAP system that we can teach it.
But still, actually, in an enterprise setting, industry setting, let's say a warehouse, you have a fresh robot, and the robot maybe knows nothing about your warehouse. So, would it basically mean that when you give a robot a task for the first time or a set of robots and they don't know, the tool might respond with something like, thank you for the task, but I don't know how to do it. What's the next step? And then the agent, like in this case, Joule, might come up with the solution like, go ask Sven. He will carry you around basically or show you. And then maybe the first time the robot walks with a human, sees what the human is doing. Is that something that's thinkable, really? Like that this is how and use a human for the training
fresh
data?
robot comes more like he would know what to do.
Yeah.
He not be like, I don't know where to move. He will have understanding of surroundings. He will kind of have idea maybe where the big boxes are because he will have understanding what warehouse is.
Yeah.
But we're not saying now how we work in my business. And then he will say, hey, I'll talk to Sven. He might have insights. How do I do in this situation?
Yeah.
So that could be the collaboration.
I know we say this in a funny way, but that's actually a kind of cool example because today that's what you can't do with traditional robotics, right? If you can't do it, it can't do it. That's it. You have to buy new robots.
Yeah, yeah.
Whereas
good point.
here you actually have some more options. Maybe not as
And
Sven,
this is also
but
interesting when it comes to human in the loop, actually, right? So this is like from an agentic pattern perspective, right? So human in the loop means like you go ask back to the human what should be the next step or if this is correct what you've done actually. And this it probably exists in the physical world too, right? So
100%.
And one of the first use cases are actually focusing on enable to help people not to doing these hazardous jobs. So really to go to dangerous places, heavy places, also intensive physically that you don't have to do it as a human, but you can see supervise if it's properly done.
Yeah.
That's one of the first use cases, not just warehouse picking boxes.
Yeah. Interesting, yeah, very cool. So should we maybe talk a bit more about the challenges that you still see? I mean, there has been a lot of advancements in AI and robotics, right? That now it needs to come together. And we talked about standardization as a challenge, for example. And what other challenges do you see actually?
Do you want to talk about the hardware maturity?
Yeah, I think that's what was on my mind. The dexterous hands. I think this is the game changer. Once we reach that stage when you can actually have the human-like grip, that will enable much many use cases. I mean, even now we have one of the customers saying, if you can help me get rid of the plastic from my package, that will help me a lot to improve my business. You can feel like, oh, just remove it. But for robot, this is a different game. And they are almost there. I think we were able to train maybe a few months to overcome that challenge. But there's little things that dexterous hands, perception models interpreting the world, the real world.
I think those are like solutions, but I think like generally it's like for hardware maturity, like depending on what you want the robot to do, it's not 100% there yet, right? So like you have like the walking is one thing, which not every robot needs to walk. Wheels are just fine if the floor is flat. Or drone, right? If you need to fly up high. But I think the second thing is like now the dexterous hand, it's really the picking and the manipulation. This is easy for us, but it's hard for robots. You don't have data sets that like are usually how hard do you grip things, right? With dexterous hands, you have tactile sensors that can actually record.
They are pretty cool.
To break the package.
And also it depends on different materials, right? So like to pick up a glass is a bit different.
Exactly. We have one partner where you can actually see the sensor data whenever you touch and how much force was put in and until how much you can keep pushing until things break. So the technology is there, but they're still getting there to be like
maybe fun fact, if you guys like health, this dexterous hand, it's from a company that used to do prosthetics for amputees. So they have a lot of existing knowledge in how hands work. So you also see this, right? So like some transfer knowledge across different uses. So
interesting. And how much does legislation play a role here, actually? Right. So I mean, are we right now actually allowed to put a robot into a warehouse and just let it move around together with humans, or what else has to happen here? So.
Yeah, that's a good point because that's one of the factors that stops us from going faster. There are not so much regulation, and also the robotic vendors themselves don't know exactly what they need to fulfill to be able to bring robots to production. Safety is one of the big factor.
Working in the same space as humans.
Exactly.
That one also bring up.
Another different parts of the hardware that some require different certification. That this is also another one challenging.
But maybe to mention, it's also not just like total Wild West. I mean, there's plenty of regulation for like IoT and just like regular machines, right? I think the challenge with these kind of smart robots, whether we call them cognitive robots or what, is that they're like in an intersection of the AI regulation and all of the regulations around like workforce and all of the
IoT.
machinery
Yeah.
stuff.
Mhm.
And then all the companies in the space are building stuff super fast,
Mhm.
whereas
And they have
regulations take
they have
time.
pieces of all of this
Mhm.
together mixed, and then we have to explain
Yeah.
what is supposed to be doing, and they regulate
Yeah.
like. So is it chainsaw-like, or like
Yeah.
we
Or like if you give
had
it a
some cases we
tool
put on the
for
chainsaw
the hand,
category
are
of
you?
dangerousness.
Yeah.
Okay.
Okay.
Yeah.
So from that perspective, it's like there's a lot of regulation, but no one knows exactly how those are going to apply to these kind of robots from like this class, right?
Oh,
There are some
yeah.
ISO standards that they're really fulfilling, but still the confidence that yes, I can bring this to workplace,
Yeah.
it's not there yet.
It's a good question.
So what do you expect to happen over the next, let's say, 5 years, 10 years? Andreas, say a number. So,
Like one.
One
like
year.
the space is moving so fast, but
Yeah.
like
That's true.
I guess
wanna-
we're still after the more like long-term perspective.
Mhm.
Like where are we going to end up with all of this?
No, I'm pretty confident that in a year from now, you will see in Europe real humanoids performing tasks in warehouses and logistics.
Mhm.
This is coming. It's already productive in China, and we just bring them over here.
Mm-hmm.
But the next step, more like humanoid or on legs, that will take more time from the hardware perspective, and I think also from the applicability, because there's no steps. Why do I need humanoid? And lots of the places are just flat, as you said.
Yeah. No, there I agree. I think it really depends on the use case, right? Like legged humanoids are very cool. Maybe for some purposes they will come sooner than we think. But question is like, would you need them as a customer? Maybe you're fine with just the wheeled ones. If they do the job, then they
Also,
do the job.
I think the challenge also is how much they can carry. Because more than they're looking cool, they can get 5 kilo each hand. Like a customer said, I need 25, 30, or 50 to be able. And then it's like, okay, the hardware has to handle this. So this also
this robot
these
can do that.
adjustments.
Like,
Yeah.
I do remember. I don't have a particular reference, but I do remember having seen like YouTube videos of wheeled robots doing food delivery, and that's totally fine as long as my food arrives.
Yeah.
That's totally fine.
Like I can pick that up in front of my door if it gets there.
So now you're gonna have a robot that picks up for you in front of your door, bring to your couch. Where
Yeah,
you sit. That's the next.
No, you need a
robots
drone
working
to
together.
fly the
And-
food to the robot.
And it's maybe an interesting discussion for the end also, right? So I think in pre-chat we talked about all these cool videos that you see online of robots walking to your door and delivering something, blah, blah. A lot of these things, I think you said it, or you, Lukasz, I'm sure, are kind of remotely controlled, staged experiences, more or less, right? So how much of that TikTok-style robot videos is real?
Yeah, I think what thing you see online is more likely remotely controlled.
Yeah.
But that's just to demonstrate what hardware can do. The next step is this autonomous training, and that takes much more time. But we're seeing some early success stories, and I think there's also the training takes time because you can train robots physically and you can show 8 hours how to pick things and it can do it for you, or you train in virtual reality, but then the virtual reality has to be very, very good quality. It is also hard to do. It takes how much effort and budget. I mean, we could find the balance, but I think we see coming. Also at TechEd, we have the autonomous robots also demonstrating.
I mean, maybe I would add to this because I didn't have a hardware background before. For me, what was interesting is that some tasks are actually easier than I thought, like backflips, right, for robot dogs. But other tasks are quite hard, like knowing the right item to pick up and doing it in a certain sequence.
Like, wait, did you just say a backflip is easy for a robot to do?
Generally, yeah, that's a physics problem that has solutions.
Yeah, so physically you can do,
You
but
can
then
do it. You can do it.
train the
I
robot
can't
to do
do that.
autonomously when you need it.
It's not an easy problem. I can't do that.
But
It's
this is
exactly
what
the-
I
I mean-
meant. Some things are easy for robots that are not necessarily the things that you
Okay,
would think,
yeah, that
right?
makes sense.
And other things
Yeah,
are a bit
yeah.
hard. Or like how to know when the task is completed.
That's why we see those TikTok videos, because it looks so impressive for a human.
But
I think it's
the hardware
interesting.
is physically capable. Those videos are
It's-
true. Like,
From a human robot perspective, it's also a bit the other way around. Like for me, it's easy to pick up this glass here actually, but it's very hard to do a backflip. I mean,
yeah,
so-
yeah.
As Andreas knows. So.
We have a whole
I
life
haven't
training how
tried
to
it.
use
Maybe it's really
Yeah,
easy.
yeah.
Yeah, I don't know.
Interesting.
And then you got clumsy people.
Yeah.
That's,
Well,
yeah.
Cool.
I guess lots of interesting insights. Thank you for sharing that with us.
Yeah,
Guess we
thanks a
spend
lot
our
for being here.
afternoon.
for
Guess we
inviting
spend
us.
our afternoon trying to do backflips now.
Yeah, exactly.
Right,
Let's
right.
go out to the calisthenics park.
Awesome. So
Thanks everybody for watching. Okay.
Thank you for
Thanks,
watching.
Thank you. Bye bye.
Ciao.